Friends, welcome to the tutorial series on network analysis made simple. In this tutorial, previous year gate questions based on Ohm's law and Kirchhoff's laws are solved. Friends, this series is a gateway for gate aspirants in NA. Emphasis on thinking process and strategy is the highlight of this series. I hope this tutorial ignites some of your thoughts. Let's go ahead. Friends, first let us solve question of GATE 2014. In this question, we are required to find the magnitude of the current in milliamperes through the resistance R2 in the circuit shown in figure. Observe the network. The network has 4 junction nodes, 6 branches, and 3 loops. The network also has 2 current sources, one of 10 milliamperes and the other of 2 milliamperes. The network can be solved using only KCL and KVL. Also note that all the resistors are in kilo ohm and all the current sources are in milliamperes. Current in 1K resistance I in milliamperes is to be found out. By applying KCL to junction node A, we get I2K is 10 minus I milliamperes. By applying KCL to junction node B, we get I4K is equal to I minus 2 milliamperes. Similarly, by applying KCL to junction node C, we get I3K is equal to I milliamperes. Now, by writing KVL for the loop DCBAD, we get 3K into I plus 4K into I minus 2 plus 1K into I minus 2K into 10 minus I is equal to 0. By solving this simple equation, we get 10I is equal to 28 and I is equal to 2.8 milliamperes. Hope you understood it. Friends, next we shall solve question of GATE 2009. In this question, we are required to find the equivalent capacitance of the input loop of the circuit shown in figure. We know that the input impedance Zin is equal to Rin plus or minus Jxin. So, to find the input impedance Zin, we need to find Vin divided by I. Observe the network. By applying KCL to junction node A, we get current in 100 microfarads capacitance is 50 I amperes as shown in figure. We also know that if Zin is equal to Rin plus or minus Jxin, if Xin is the capacitive reactance, then X is equal to 1 upon omega C, from which we can find the capacitance C. Now, by writing KVL for the input loop, we get Vin minus 2000I minus 50I minus J1 upon omega C is equal to 0. Or by solving and substituting the values, we get Vin divided by I is equal to 2000 plus J into bracket 1 upon omega into 2 microfarads. From the equation, we find that Zin is equal to 2000 plus J into bracket 1 upon omega into 2 microfarads. Hence, C is equal to 2 microfarads. Hope it is clear to you. Friends, next we shall solve GATE question of 2010. In this question, we are required to find the power delivered by the voltage source. Observe the network. The network has 4 junction nodes, 6 branches, and 3 loops. Also, the network has two current sources, one of 1 ampere and the other of 2 amperes. We know that the voltage source delivers power if the current leaves the positive terminal of the source. In the given network, the current I leaves the positive terminal of the source, hence it delivers power. We also know that power delivered by the voltage source P delivered is equal to V into I watts. This problem can be solved by using KCL and KVL, friends. Observe the network. First, by applying KCL to junction node C, we get current in branch CB is equal to 3 amperes. Next, by applying KCL to node B, we get current in branch BA is equal to 3 plus I amperes. Similarly, by applying KCL to node A, we get current in branch AD is equal to 2 plus I amperes. Now, we know all the branch currents. Hence, by writing the KVL for the outer loop BADB through voltage source V, we get minus 2 into 3 plus I minus 2 into 2 plus I plus 10 is equal to 0. By solving this simple equation, we get 4I is equal to 0 or I is equal to 0. Hence, power delivered by the voltage source P delivered is equal to V into I and it is equal to 0 watts. Hence, option A is the correct answer. Friends, are you surprised that the power delivered by the voltage source of 10 volts is 0? Yes, it is true, friends. If you want to check, find the voltage across both current sources and their polarity. You find current source of 1 ampere delivers 9 watts of power and current source of 2 ampere delivers 26 watts of power. So, total power delivered is equal to 35 watts. If you find power absorbed in all the resistors, you get the total power absorbed is equal to 35 watts. Hope you will check it. Friends, next we shall solve interesting problem of GATE 2014. In this question, we are required to find the energy supplied by the mobile battery in 10 minutes of talk time. It is given that the current supplied by the battery during this talk time is constant at 2 amperes. It is also given that the battery voltage linearly drops from 12 volts to 10 volts during the talk time of 10 minutes as shown in figure. The problem seems to be complicated but very easy, friends. We know that energy supplied by any source E is equal to integration P dt, or it is equal to integration V of t into I of t into dt. I of t is constant equal to 2 amperes. So, E is equal to 2 into integration Vt dt. But you know, integration Vt dt is the area of the variation of the voltage with time. So, E is equal to 2 into bracket 10 into 600 seconds plus half into 600 into 2 volts, and that we get energy supplied is equal to 13.2 kilojoules. Hence, option C is the correct answer. Friends, next we shall solve GATE question of 2013. In this question, we are required to find the current Is in the voltage source and voltage Vs across the current source in the network shown in figure. The problem can be solved by using KCL and KVL. Observe the network. Note that 10 volt voltage source is connected across 1 ohm and 2 ohm. So, current through 1 ohm is 10 amperes and current through 2 ohm is 5 amperes as shown in figure. Friends, the answer options are shown here for convenience. Observe the network. By applying KCL to node A, we get current from B to A is 8 amperes. Note 2 ampere enters and 10 ampere leaves, so 8 ampere enters. Similarly, by applying KCL to node B, current from C to B is 13 amperes. Note 8 ampere leaves, 5 ampere leaves, so 13 ampere should enter. But observe that the given direction of Is is from B to C. So, the current through 10 volt source Is is equal to minus 13 amperes. Note this. Now, by writing KVL for loop CBAC through the current source, we get plus 10 plus 5 into 2 minus Vs is equal to 0. By solving, we get Vs is equal to 20 volts. Hence, option D is the correct answer. Friends, next we shall solve GATE question of 2000. In this question, we are required to find the voltage V of t across the inductance in the network given. Observe the network. Current e to the power of at enters node A and current e to the power of bt also enters node A. So, current through the inductance equal to e to the power of at plus e to the power of bt should leave node A. But we know voltage across the inductance V of t is equal to L into di by dt. Hence, V of t is equal to L into d by dt of e to the power of at plus e to the power of bt. By substituting L is equal to 1 Henry and solving, we get V of t is equal to A into e to the power of at plus b into e to the power of bt. Hence, option D is the correct answer. Very simple and easy, isn't it, friends? Friends, finally, we shall solve GATE question of 2015. In this question, we are required to find the values of V1 and V2 respectively. Note, V1 is the voltage across 2I ampere current controlled current source and V2 is the voltage across 5 ampere current source. The given circuit has 2 junction nodes, 4 branches and 3 loops. The problem can be solved very easily by using KCL and KVL. Observe the network. Consider node A, 5 ampere enters A and I amperes leaves A. So, by applying KCL to node A, we get current from A to B is 5 minus I amperes. Similarly, consider node B. 5 minus I amperes enters B and 2 I amperes leaves B. So, current from B to C is 5 minus I minus 2I equal to 5 minus 3I amperes. Friends, now we know all the branch currents. So, by writing KVL for loop CBADC, we get 4 into 5 minus 3I minus 4I is equal to 0, from which we get 16I is equal to 20 and I is equal to 1.25 amperes. But V1 is the voltage across 4 ohm resistance. Hence, V1 is equal to 4 into 5 minus 3I. By substituting I is equal to 1.25 amperes and solving, we get V1 is equal to 5 volts. To find V2, by writing KVL for loop D to A to D through 5 ampere source and 4 ohm resistances, we get V2 minus 4 into 5 amperes minus 4I is equal to 0. By substituting I is equal to 1.25 amperes and solving, we get V2 is equal to 25 volts. Hence, option A is the correct answer. Friends, in this tutorial, we learned to apply Ohm's law, KCL and KVL to solve seems to be complicated problems. Though gate questions seem to be complicated, their solution will be simple. For that, we need to apply our mind, think for a while, understand the network connectivity, analyze the given data to arrive at a simple solution. Friends, I hope this tutorial has ignited some of your thoughts. If so, please forward your feedback and suggestions to my email. Thank you for watching this video.